Welcome back to another video. Today, we're looking at a project born from years of frustration. After countless hours dealing with messy traditional prototyping and the long wait times of ordering custom PCBs, I decided to take a different path. I wanted to see if I could create my own clean, organized circuit boards right at home, using nothing but a 3D printer. This is a 3D printed PCB. Instead of relying on factory-made copper traces, this system uses the physical geometry of the print to route the logic. Precise channels are carved into the plastic, allowing 26-gauge wires to act as the internal circuitry, creating a structural nervous system for electronics. This project is one of the early designs that served as the foundation for the entire ecosystem I'm building today. In this build, we are utilizing the Raspberry Pi Pico paired with a 50/50 RGB LED module, but we aren't using a single drop of solder. We are using pure geometry to complete the circuit, a proof of concept that would eventually evolve into a much larger family of instruments. Stick around to the end, and I'll show you how this simple RGB experiment became the spark for a sophisticated world of sensory-aware hardware. The wiring is intuitive and straightforward. You don't need to learn complex soldering techniques to build high-quality, functional instruments. Unlike the rat's nest of a traditional breadboard, 3D printed PCBs are neat and organized by design, with every trace mapped into the chassis. All components are reusable. Assembly is quick. It is significantly faster to wire these channels compared to traditional soldering, allowing you to move from prototype to finished object in minutes. By removing solder from the equation, there is zero lead-based exposure for the builder. You avoid the risks of electric shock when working with powered soldering equipment. There is no risk of burns, and there is no off-gassing from flux or chemicals from PCB etching. The architecture is simple but powerful. We're using the Raspberry Pi Pico, a dual-core microcontroller, to drive the logic, and a standard 50/50 RGB module for the visual output. To make assembly foolproof, the logic is mapped directly into the geometry. The printed traces act as a physical guide, routing each wire from the microcontroller to the correct socket. While the board labels assist with your code, the structure handles the hardware. Full diagrams are on my site, but the design is built to let the chassis do the work for you. This project is one of the early boards that served as the foundation for the system I use today. It was the proof of concept that proved 3D printed circuitry was a practical reality. Since then, the system has evolved far beyond these early experiments into advanced instruments that can map and protect your environment. We are just scratching the surface of what's possible when we combine additive manufacturing with modular electronics. To see how this simple spark evolved into a growing ecosystem of hardware, subscribe, and join the journey. Files for this foundational build are on my site. If you know a maker, share this video with them to try it out. Thanks for watching, and build the tools that give you the power to own your world.